All right, this is sort of a IPFS operators special meeting. We had our kickoff meeting last week, and this week Hector has graciously offered to give us an overview of how IPFS cluster works, and we'll have a discussion afterwards about how people might start using IPFS cluster, or feedback on running IPFS cluster, people's experiences so far. But in the meantime, Hector, if you just want to take away, share your screen if you have slides, and get going. That's an extremely wide monitor, so.
Yeah, thank you. Yeah, I don't know what you see as screen. Am I sharing the whole screen or just oh yeah, we're sharing the whole.
Great, that's much better. Thank you very much. Yeah.
Yeah, I prepared the video presentation, and I'm gonna talk about the IPFS cluster project, why we use cluster, how we use cluster, roadmap, and then we can discuss about things. It should be relatively short and to the point. Cluster started in 2016, captained by myself. The first record that I have about putting it in production for storing stuff on IPFS is on 2018. We needed a big storage cluster, and we had 5 nodes, and we used cluster with it, and there's some infrastructure automation, and they're still there, and the first commit was from 2018. Since 2019, we have also smaller clusters we call them collaborative clusters, because they're potentially they can be joined by followers, by anyone that is interested in following certain type of content. So we have a collaborative cluster, which is only to store websites like IPFS.io, the cluster website, and the protocol labs research website, this kind of thing. We have that since 2019, and currently cluster is an off-the-shelf tool. We use it, we maintain it, but there's no active team assigned to it. During the history of cluster, the team size fluctuated between 1 and 4 people. The goals of the project: simplify storage replication and scaling IPFS storage, provide a sane API for use as a storage service on IPFS, facilitate the distribution of things to pin to other nodes, to other people, to followers. And there was an original goal, especially in the early years, which was build something on the IPFS stack that is not IPFS itself. It was the time before Filecoin. It was the time before a bunch of other things were relying on IPFS libraries. And therefore, cluster was very useful back then, just to make sure that things were reusable, that things could be used independently for something that was not IPFS itself. Features. When you build an IPFS cluster, what you're doing is putting some peers next to your IPFS peers. So putting an additional application, an additional sidecar to IPFS, which maintains a global pin set, meaning that those peers will have visibility into a list of pins which apply to, which is the same to all of them, but that doesn't mean that they have to pin everything we will see. That list, that global pin set that every peer in the cluster has access to, has a list of CIDs that then has a list of properties for each CID, which can be the replication factor. You can add any random metadata. You can add pin name. You can now add pin origins, and you're able to ingest pins into that global pin set very fast. follower peers in a cluster can just track this global pin set and pings the things that are being pinned in the cluster. We have a REST API. It has SSL certificate support baked in the configuration. It has basic authentication. It has request logging. It has CLI and Go clients, which have full parity and rely on and provide full functionality to the API. So it essentially is a little bit better for pinning than what the IPFS daemon API offers. It just makes more sense in general. And you can consider, now we have the pinning services API, which is partially based on a bunch of things that the cluster API was using, and it shouldn't be too much work to actually provide pinning services API on top of cluster. I think we have all the primitives that are necessary for that. There's an additional second API, which is an IPFS proxy API, which acts just like the IPFS daemon API, meaning you can query the same endpoint with the difference that the pin endpoint and the unpin endpoint are hijacked, and that trigger a cluster pin or a cluster unpin rather than forwarding the request to the underlying IPFS daemon. So that was thought as a way of being able to drop a cluster where an IPFS daemon was running before. Cluster is supposed just to make things easier when you're pinning stuff on IPFS and building a storage service on IPFS. Pinning is asynchronous. You ingest a bunch of pins in the cluster, and the cluster will take care of tracking them, making sure that they are pinned, and making sure that they time out if no more blocks are coming, making sure that they are retried later, making sure that they are allocated to the peers in the cluster which have most available storage, making sure that you as an operator can query the status of the pin and see which pins are pinning, which pins are in error, in which peers, and making sure that you can configure your timeouts, that you can configure how long you wait for things, that you can configure how many things you're pinning in parallel on every node, etc., etc. It should be operator friendly in the terms of all the configuration can be specified with environment variables, which make it very suitable for Kubernetes deployment. The identity is separate from the configuration. Again, the configuration you don't have to persist it, that the identity needs to be persisted. The configuration can be fully specified via env vars, so this separation makes sense. It is Dockerized with official Docker builds, and it has like many tweakable options. It gives you access to all the data store low-level options. It gives you access to control many timeouts and a bunch of things that, for example, IPFS doesn't give you options to tweak all the Badger data store behaviors, and it chooses them for you to the most part. Cluster prefers to just expose those things. And the documentation is up to date, it's accurate, and it's maintained, which is always a big plus. Why we use it? Very low maintenance. It kind of just works. We run it, and it doesn't give me too many headaches or to our infra team. We can send a pin, and we can check. Usually things will become pinned, and you can wait for them to become pinned, or I can just check later if the thing was pinned or not pinned and what was the error. And this API that is offered also integrates nicely with GitHub tooling, for example. So we have this integration where when we commit on GitHub for a website, there is a CI job that will build the website, pin it on cluster, and send you back the URL. And this just plays nicely with things. The API is authenticated, so you just can build things around here. And of course, other applications like NFT storage, the front-end nodes are then sending pins to the cluster as a backend, and that also plays very well. We have Ansible automations for deploying clusters. So creating new clusters for us is more or less painless. We run a few, and I will go through the list in a minute, but it's not much work. And it solves the problem of replicating stuff that we want on multiple nodes. So it solves the problems of IPFS storage for us, whether that is just random things that we want to keep pinned on IPFS because people send them over a Slack bot, or the FileCon parameters, or the IPFS website, and so on. So it solves the problem of distributing that content to multiple nodes. And of course, we use it because it has an active steward, and that is myself, meaning that it is maintained, that the versions are up to date, that the dependencies are up to date, and that the reaction capacity also, because it's a project with not many dependencies around, means that I can provide API features, I can provide bug fixes, I can provide performance improvements, hopefully relatively quickly with a quick turnaround, something that we cannot do so flexibly in IPFS land. For example, if you want to get something on IPFS land, the whole release cycle is going to be way longer and way more complicated because there are like way more things to pay attention to. But if we want to suddenly expand an API in IPFS cluster to fit in certain functionality that we need, we can do that relatively quickly. And since I'm there, everyone gets premium support. And now as IPFS operators, you also have this support because you have access to me. So I've already been helping some of you with some issues in this front. How we use it? Yeah, we have a legacy cluster. It was the first one, 5 cluster peers on CRDT mode. There are 2 modes to run cluster using CRDT or Rust. CRDT is way more flexible, but this cluster was also running Rust for very long. There are big nodes, 64 gigabytes of RAM and 40 terabytes of usable storage each. And the storage is filled currently around 7 terabytes on each of those nodes. And it has 208,000 pins replicated with factor 3. That means out of the 5 nodes, every pin will be pinned in three places. We still send a bunch of stuff here by default. Websites, I think Wikipedia's, where at least the old Wikipedia's, we think we have them in there. All the builds of our binaries are still in there, even if they're pinned somewhere else in some of our newer clusters. We still throw stuff in there. The Twitter bot, the Slack bot, there is someone sending XKCDs. Some people from the origin protocol also had a username and password, and they were using it as backup also to pin things directly on this cluster. So it is pretty much alive, but it's a legacy cluster in the sense that it is the old one that has been running since very long on relatively small hardware compared to our new clusters. So we run several collaborative clusters. I think we run 3 or 4 or maybe 5 on the same hardware, meaning we run several cluster peers on the same machine, and those cluster peers belong to different clusters, but they're all on the same machine and they're all reusing the same IPFS daemon below. You can do that because the content that they're pinning will be different between them. So they're not going to be pinning or potentially unpinning the same things. So there's no overlap between the content that they're tracking. In this case, the nodes are bigger, 48 cores, 192 gigabytes of RAM, 90 terabytes of disk, and we're using around 6 terabytes of disk, putting all these clusters together that are on the same hardware. Replication factor everywhere. So we have 3 nodes, and all of them will be replicating content. And the reason here that the replication factor is not 3 is because these collaborative clusters are open and anyone can follow them. So a user may launch their own cluster peers using IPFS cluster follow, which is an application. that we provide, and they may join the IPFS website cluster. And therefore, replication factor is everywhere. That means when people join, they will also start pinning the content. But in general, in these clusters, there is a low number of pins, even though some things are big. So in the Wikipedia cluster, there will be a few pins, but the Wikipedia snapshots are very big. There's a Filecoin params cluster, which has Filecoin params that we were going to use to distribute them in China and so on, but in the end, we didn't follow IPFS distribution for params, I think. And yeah, in general, that's running there is our new clusters. And what came up lately was the most recent cluster is the NFT storage cluster, which has dedicated hardware, but it's the same type of hardware as our previous clusters. And there we have 10 terabytes of a storage used per node and 2.6 million pins. Because of the requirements, we made a release to cluster before the latest one, where we added something called pin batching, because we needed to ingest a lot of pins to the cluster, and ingesting them one by one wasn't good enough. With this feature, we measured 170 pin add operations per second from a developer machine. We think the bottleneck was in the developer machine, and we churned through 1 million pins. So I think we added like 1 million pins to the cluster in a relatively short time. And then the cluster churned through that queue. So you cannot pin everything at the same time, and it's going to take time. But it went churning through that queue for like 2 days, slowly making sure that everything got pinned until everything was pinned, and everything is tracked correctly in the cluster, and everything is pinned on IPFS. For setup and deployment, we use Ansible. As you saw, we tend to use big hardware and bare metal. So the previous boxes and so on are on bare metal. Not for cluster itself. Cluster is not overly demanding, but IPFS, particularly with big repositories behind, we found it is better to just have really big boxes, particularly if those IPFS daemons are at the same time not only storing and providing content, but also serving as gateways and serving traffic. Yeah, some people are running with Kubernetes. I know some are in this call. We are not running with Kubernetes, though, but we'll be super happy to hear your experiences. And roadmap. We are not committed to larger complex endeavors. So there is a list of things that we could do that will require significant development time, and we don't have a space to do that. We don't have anyone assigned to suddenly spend a few weeks working on those things. However, there is a commitment to user support, to maintenance, to bug fixes, and hopefully to meet our scalability needs. So make sure that if there is like very low hanging fruit, like enabling pin batching, so that we can ingest way faster pins, because we need to pin a bunch of things for NFT storage. So that kind of things, which are relatively easy features, we took on them, and we take on them, and we deliver them, and then we make releases. The only exception that we have on the roadmap right now of something that would be moderately complex is the implementation of the pinning services API. So to put an extra module to implement that on cluster, and I think I'm going to get the chance to work on that relatively soon, maybe in August. And that's it. We can discuss.
Awesome. Thank you. Jazz hands, as is tradition. Questions?
Yeah.
I have one. Oh, go ahead. Yeah.
Thanks. Yeah, so I guess my question, I haven't run IPFS cluster before, so I'm interested in like what the topology of this looks like. I think you mentioned in one of the cases, you're running like multiple clusters in the same machine, and they're using a single IPFS daemon. Is that correct?
Yes, that is correct.
Okay, so basically, IPFS cluster is kind of its own library, and yet it runs like its own process and then connects to an IPFS daemon. And so essentially that's allowing you to kind of do the pin replication, but it's not necessarily scaling IPFS itself, right? It's just like scaling the data and adding redundancy there.
Right. It is kind of simplifying if you're going to run several IPFS daemons and you're going to use them to store things. It is simplifying how you tell them to store things. So it is a way of orchestrating a little bit the fact that you don't want to pin something on a single IPFS node, but you actually want to pin that thing on several nodes, and you want that happens, but you don't want to be waiting on your API call to come back, because it may be something very big. So you want it to be tracked in the background, and you want to be able to check what is the state. Is it pinning? Has it finished pinning on what nodes, and so on. So it's providing that kind of functionality.
Do you have any use cases where you have multiple IPFS daemons that are connecting to a single IPFS cluster?
So a cluster is its own set of peers, and each peer is a sidecar to the IPFS daemon. So you normally start IPFS, and then you start a cluster peer next to it locally on the same machine. And that means that you cannot have like one cluster peer talk to several IPFS daemons. You can add more cluster peers to the cluster and add more daemons to the cluster. This is how it will go.
Okay, thanks.
Okay, I can go next. First, I must say that it's true that Hector does a really good job in giving support to IPFS cluster. I've been talking with him like quite frequently lately, and like the response times are great. So thanks a lot, Hector, for your support. My question is related to how to do correct operations regarding garbage collection in IPFS cluster. I had the sensation that it's not totally safe to run garbage collection in the cluster while you are adding data and pinning it. So maybe if you are adding data and pinning it and you run garbage collection concurrently, you may lose part of the data that you are about to pin next. So that sounds like you should disable garbage collection to be run automatically, and you should maybe take out a node from the cluster, and then to be completely sure you are not adding data, and run garbage collection and put it again. I don't know if you have any thoughts, or there's some kind of good practices how to deal with that.
Yeah, the practical approach there is disable any sort of automatic garbage collection, and only run garbage collection when you know that you're not adding to that cluster peer, or that perhaps you're adding to that cluster peer, but you will be also adding to other peers at the same time. Therefore, if something gets garbage collected on that peer, it will be able to retrieve it again when it finishes pinning. But yeah, the practical approach is that what happens if you add to cluster will do all the chunking, all the chunking that IPFS normally does before storing the stuff. Cluster is going to do it in the cluster peer. And the way it adds content to IPFS is by doing block puts on the IPFS daemon. The good thing about this is that you can send those block puts to multiple IPFS daemons around the cluster at the same time, which is very useful if the things are small. And the second advantage, which is not used, is that cluster wanted to support DAG sharding. So for very large content, it wanted to be able to split the DAG among several IPFS daemons and not store a single DAG that is too big on a single daemon like right now. But the way pinning works on IPFS, there is no way to specify that you don't want IPFS to store the whole thing once you pin it. But it was very useful to be able to send blocks individually, because you could actually do the splitting of the DAG. The solution there, yeah, if you're doing block puts and then you GC before the thing is pinned, the GC will delete those blocks that are not pinned. So the solution there right now is to not GC, or you can potentially expose the IPFS daemon API directly through that API, which should block GC, and then use cluster to pin. But that is the gift of that very. It's a long-standing issue, but IPFS also doesn't give a way to programmatically say, hey, wait, I'm doing a transaction here. Please do not run GC. Please allow me to disable GC while I'm doing this thing. There's no way to do that. And there might be like, yeah, there's like no good solution. There could be like some MFS hacks, but it's also like nothing good there. So yeah, don't do GC at the same time. You need to rotate. You need to be able to say, okay, this node is not receiving requests for adding stuff to it, and while that is not happening, I'm going to do the GC operation.
Okay, cool. So it makes sense to you that I can simply disconnect an IPFS cluster node from the cluster and run GC directly in the IPFS node, and when that finishes, put it again. That seems like a reasonable approach.
Yes, if you're using CRDT for the backend, which is the default, you can just take the node offline, wait until the metric expires, which I think is something like 30 seconds or 1 minute, so that every other peer in the cluster will see that this peer is no longer there. Therefore, if a pin request comes, it won't be allocated to that peer, or you won't be adding to that peer. And when that happens, you can then run your GC operation, start your cluster peer again, and the cluster peer will sync up to the latest state and keep going.
Cool, thanks.
So one of the things I wanted to ask is, so I guess PL is running this, but as far as I know, does anyone else on this call actually run IPFS cluster in production?
We aren't running it yet in a production environment, but we are planning to do so.
At Textile?
Yeah, and also we are running cluster in Kubernetes. So yeah, we feel like it's a good match. All the things that Hector mentioned about tuning things via environment variables and having the PRD be kind of separate from the configuration are really good things for like a Kubernetes deployment. So we're pretty happy with that.
Yes, so Textile and Fleek is also using it or planning to use it.
Yeah, I guess I was wondering, again, basically, because we're trying to figure out from an operator group perspective, how to share best practices and, like where to do that. So I know us at Fission ran IPFS cluster and had to turn it off because it caused issues in production. We don't need to kind of dig into that now. And I think in the other kickoff call that we had, there wasn't anyone in the operator group that was running it in production. So Matt, I don't think you guys run cluster, right?
Yeah, yep, that's correct. We kind of opted to build our own clustering solution for a variety of reasons.
Care to share any of those reasons that might be helpful in others considering it?
Sure. Yeah. Just kind of high level. We were working on some stuff with, we called it regions and replications. So letting people be able to choose how many things they wanted replicated in each sort of region of the world. Can you guys hear me all right? The thing stopped showing for me. Okay, perfect. I don't think Cluster had that at the time. I think I saw that on your roadmap actually, Hector. So that looks like something you guys are considering. And then also just kind of, for us, it brought in two, what would I call it? Two ultimate sources of truth, which was something we didn't want in our system. So, you know, we had our Postgres database, which kept track of all the pins, and then IPFS cluster would keep track of all the pins. And then I think at the time, every single peer was keeping track of every single pin, like the entire pin set, which we weren't sure how well that was going to scale. So granted, I do want to put out here as kind of a disclaimer, this decision was made about 2 years ago. So I think Hector's made a lot of improvements to IPFS clusters since then. So I don't want to, my anecdotal experience to be too dissuasive for anybody here.
Are you able to tell how many pins you have, Matt?
How many pins we have right now?
Yes.
I don't know off the top of my head. I'd have to check that. We're working in, I'll say it's in tens of millions for sure, but I'm not sure the exact number. So
yeah, thank
you said that your NFT storage cluster seems to be doing all right though, and you had a few million pins there.
Yeah, we have 3 million.
Okay.
Well, 2.8 when I look, maybe it's 3 now. The main issue there, for example, is if you want to list all pins, like if you do the pin ls, I think it is, yeah, it is like the one that was 200K pins, it was 800 megabytes of, the list of pins was 800 megabytes. So the list of pins with the metadata and some serial explication. So the operation of listing 2 million pins, of even doing the pin ls on IPFS, if IPFS has 2 million pins, it is slow. So that one takes minutes. But other than that, it's not an operation that the cluster needs to do very often. So
yeah, I was curious. I think I remember when we were initially trying it out, every single query operation against the cluster went out to every single peer in the cluster. Is that still the case?
It depends. If you check the state node, if you want to check an individual item in the state and see if cluster is pinning it and where it's pinning it, that's the shared state part that doesn't go to every peer. If you want to know what the status of a pin is, whether it is actually pinned on IPFS on the peers in the cluster, that is an operation that goes to those peers and asks, hey, please, can you tell me, can you actually go and ask your IPFS peer if they are pinning this thing that it should be pinning? And that goes to every node on the cluster. But there has been, I think there's an optimization there that if the pin has replication factor 3, and it is only supposed to be pinned in 3 places, only those 3 places will be actually asked, not all the other peers that are not supposed to be pinning it.
Yeah, I think that was one other kind of consideration we had was as we continue to horizontally scale out our operations, having every single request for like, hey, is this item pinned? go to every single node in our cluster could get expensive as we continue to scale out. So
but how do you want to
there's
know otherwise?
optimization.
How are you going to know if the item is pinned in every node in the cluster if you don't ask those nodes in the cluster?
You, from what you said, it sounded like you would even ask the nodes that didn't pin it, though, correct?
Potentially in the past, but this is, of all the problems, this is not a problem. This is not like every single operation. It's, you want to check the status of a pin, then sure, like cluster will automatically go and ask the peers if it's actually, it knows that the cluster is tracking the item. For that, it doesn't need to go to the pin. But to actually verify that the daemon in those places is actually has it pinned, then it has to go and ask. Yeah.
So to clarify, cluster itself knows which nodes are expected to store the data, and then it will only ask those nodes whether the pin has succeeded.
Yes, when you're done. Yeah.
Okay. Yeah, that sounds like an improvement from that 2-year point ago. So that's good to know.
Yeah, that was something we introduced, I think. I'm 95% sure that this is the case now, that we only ask the places that are allocated to the pins. Obviously, if the pins are allocated everywhere to every peer, then you have to ask every other pin. Yeah.
Yep, that makes sense.
I think one of the issues that we had was around Badger getting corrupted, but there's now an option to use LevelDB.
Yes, that is new, and because Badger was growing very, very large without needing to be so large, I added a LevelDB backend, and it can be used now, and it doesn't grow so big. But I also added garbage collection to the Badger backend that cluster uses, and I tested it, and it reduced by a factor of 100 the storage that a cluster was using on our node. So I think that is quite fine. But it was also, yeah, since as you saw, our storage nodes have plenty of storage, so we weren't really having a problem with Badger using a lot of the storage. But yeah, now that I saw that it was actually hurting some other people, I fixed it. It was good to find a relatively low-hanging fruit solution for this thing. I have never experienced a Badger data store getting corrupted, though I should say that I know that there is that risk, and that it is a very shitty risk, but I haven't experienced that, and we haven't seen him. I haven't seen that with IPFS either, and now that Filecoin uses Badger as a backend, but I think they're using the newer version, the V2. It is also not something that usually happens. So yeah, I don't know why Badger was getting corrupted in your case.
Good to know.
Since I think Matt mentioned like cross-region replication, and I was wondering about in your setups that you mentioned where you're storing data and kind of like what that topology looks like as well.
There is one node. So in these clusters, which are like 3 nodes, there is one in Europe, one in San Francisco, I think, and one in somewhere in Asia, maybe Singapore. Yep, those are the 3 things. The cluster doesn't have the fact of running the cluster doesn't add like requirements to the thing. The requirements, the hard requirements for the hardware that you run and so on are always going to be from IPFS. IPFS is the thing that is mostly going to keep the machines busy doing all the storing and reproviding and DHT operations and so on. Cluster is relatively lightweight on top of IPFS, so at least I would expect it to be.
So the actual pin data then, like what do you use for storage for that?
Batcher for the as data store backend for IPFS, we use Batcher.
Okay. And that is that like writing to like a volume, or like where does it get written to?
Yeah, to the local disk. So there, yeah, it just writes to local disk, and things are replicated into those 3 places around the world. So that is the 3 copies of something. If something happens to break or disappear, hopefully we can retrieve the copy from a different place.
Right. Cool. Thanks. That's helpful.
In our legacy cluster, I have like RAID 5 or RAID 6 configured, or RAID 2. I have RAID configured, and there are like 10 disks in a RAID array. So at least 2 of those disks can break, and the data will be there. So there's like an additional layer of protection there by making sure that the data is itself replicated on the disk. But this was an early design. I would say it's, potentially the disk breaks, and sometimes I have to replace them, but the data will be in any other case in some other peer, so it would be recoverable in any case.
Cool.
Awesome. Any other questions we have for Hector?
I got one for you, Hector. This is this might be kind of more of an IPFS issue as well, but as operators continue to scale out horizontally, and then also vertically as well, kind of making those decisions becomes important. Are there any plans with Cluster to say, utilize kind of load balancing requests to within the nodes itself, kind of act as like a proxy to all the nodes in the cluster? So, requests kind of get evenly distributed, or is most of the traffic resolution always going to continue to stay kind of at the IPFS node layer itself? Let me know if that question doesn't make sense. I think I might have confused myself there too.
There are no plans. So what we do is we put engines in front.
Okay.
We put engines in front of the cluster API, and then the pin requests are going to be distributed across all the cluster peers.
Okay.
If the IPFS daemons are acting as gateways, they will also have some sort of load balancing in front, maybe DNS load balancing simply. But other than that, that is what we do. So we just have engines in top, and we potentially rotate among cluster peers, I believe. But we also have, so DNS load balancing is DNS load balancing is probably the real thing that we have. We just have like several endpoints in the same DNS name, and then requests will go to one another. But yeah.
Are you guys seeing any sort of like max pin set size that you would recommend for cluster? I know you guys said you're running a few million for NFT.storage. I'm not sure if there's been any upper limit testing of cluster so far, and if so, what consensus mechanism you guys have used for this metrics?
Yeah, so I think cluster is going to work very well with many millions of pins, because that is just entries in a key value data store. And that key value data store is going to be more or less replicated in the cluster peers. And we know from Lotus, we know from Filecoin that scales reasonably well to many millions of keys. The question is, the open question is how many pins can a single IPFS daemon store itself? And you probably have better answer there, but you're running several million pins on a single IPFS daemon. You're running with FlatFS as a backend for IPFS, and things still work. So I think the upper limit of pins in a single box will be given by IPFS, and the upper limit of pins in the cluster, I don't know, but it will be far away. But
Okay,
as I said before, if you want to do a pin ls operation which lists all the pins, or if you want to do a general status operation which does a status for all the pins, obviously, if you have 2 million pins, if you have 10 million pins, that is gonna have gigabytes of data around, so that call is gonna take minutes to come back.
Yep.
But what I did, I recently introduced improvements for filtered queries. So if you want to do a status query, but you want to filter only for things that are pinning at the moment or that are queued to pin at the moment, that will come back very quickly. It doesn't have to list all the states like it did before.
Okay.
So that
makes sense.
Way better from an operator point of view to see, hey, like, how's my cluster doing? Are there many things which are pinning? Are there many things which are queued because IPFS does not manage to ingest all the content, and the queue is growing? So that should come back way faster, particularly with very large pin sets.
Makes sense. Thank you.
Hector, what would be your ask of people using Cluster, considering using Cluster, things that you want help with, anything that's top of mind for you?
I think the most important thing is please share when you have, reach out when you're doing that, and reach out for advice on whether what you're doing is sane or whether it makes sense to tweak some of the configuration parameters to make things a little bit better, a little bit more stable, or a little bit more sane for what you want to do with cluster, depending on how many pins you want to deal with and how many nodes you're going to have, etc., etc. That is the most important thing, to make sure that you're able to get as much value as you can from what we have right now. And then let's see where you hit the problem. Let's see whether there's something bothering you. For example, the NFT storage people, they said, hey, like, we need to ingest 1 million pins, and we tried this, and we cannot ingest more than, I don't know, 2 or 3 per second. So what can we do about it? And that was a relatively easy thing to fix with patching. But that is a good example that there are places, for example, the Badger TC issue and so on, that once these issues are brought up, there might be actually a very actionable solutions that we can push and get them fixed. There might be other issues where the solution is not so simple either, because it requires something on the IPFS side of things, which is never so simple because it requires architectural changes to cluster that we don't have time to commit for and so on. But I should be able to tell you, yeah, this is a solution that I have or that I don't have, and this is what you can expect. So this is the good thing, and this is also why it's very useful for me to say, hey, like, okay, you're using it, these are the problems that you're facing. Let me see what we can do to alleviate them, or to at least not make it suck for you as a user.
Yeah, that's great. I think we end up using things a little non-traditionally, and a little bit more like the Wikipedia use case, where there are relatively few pins where there's lots of things underneath it. So that's a kind of a different use case than tracking lots and lots of individual pins. And so we have to look at that a little more. And again, like Matt, there's the back and forth of, if you're running a database already, depending on what else you're doing, which things are we putting in cluster, or are we communicating with cluster with our account database and so on. So I think those are some areas that everyone's going to face the same sort of trade-offs and discussions. I actually don't know what Textile uses for an account system per se on their side. I guess they have API keys as well on the Textile bucket side. Val, do you have any ideas on how you guys are going to handle accounts and sort of permissions related to some of your infrastructure?
I mean, I guess as it relates to our infrastructure, mostly we are keeping things pretty open. So like Ceramic basically sits on top of IPFS. And we run like nodes for the public. We have a public test net, but also a main net where we run nodes for the public, so they can basically create, any data that they want. So in terms of permissioning, at least on the IPFS side, right now we have a setup where we just say, okay, certain clients are allowed to write to the IPFS node. And for us, in terms of like accounts, it looks a little bit different because basically any like Ceramic node, right, can ingest any amount of data. So we don't have permissions per se around data that gets into IPFS, but we do have permissions around like the particular streams of data that individuals create. And that's kind of a separate thing.
Awesome. Yeah, it's going to be good when we get some more of these pictures shared and things like that as well, so that I think we can all start going like, oh, you do it like this, you do it like that, and think about what some of the pieces are, right? So Hector's ended up using Ansible. We've got a Terraform plus IPFS cluster that we started with. Yeah, I think lots more looking at the cluster repo and seeing which pieces of those make. I think my takeaway from this, Hector, that's really great is exactly, I mean, environment variables and sort of made for being operation and sort of running this parallel network that essentially makes IPFS nodes more manageable at a layer that, like you said, can potentially change and be upgraded and be tweaked and configured at a faster cycle than core Go IPFS changes. Is that a useful summary in the way to think about it?
Yes, that is a useful summary. In fact, I have considered to integrate IPFS directly in clusters so that it doesn't have to pin things on IPFS, but that it could actually just store the content itself. That is another avenue. So for example, we don't have we just store content for archival, really. So we never delete anything. I don't have never had the need to delete content to unpin or potentially GC content so much. So for this, it would be perfectly fine to just have a peer inside cluster that you can just add directly to a block store and store. But yeah, there are a bunch of things that will potentially get worked on in the future. Some of them are easier than others. This one in particular is not too difficult, but it has to be useful for someone to actually have the buy-in and the ability for me to go out to the organization and say, hey, please give me this week so I can work on this, because it's really useful for these other people that are relying or that are expecting this. Otherwise,
Hector, could you elaborate on that a little bit more? You're saying that like an IPFS cluster that doesn't actually use an IPFS daemon behind the scenes. Am I understanding that correctly?
Yeah, so right now, IPFS has a component which is the IPFS connector, which is an API client to the IPFS peer. So it is is the thing that is in the end triggering the ping call and the unping call. Instead of that, you could just run the IPFS peer inside the cluster. So instead of that connector being a client to the actual IPFS peer, you could potentially just run the IPFS daemon inside. And of course, it would be a daemon which is just storing and announcing content. So something IPFS Lite based.
Yeah.
But you could run it from inside. But the question there would be, how do you make it in a way that it's worth it? So if you're going to still maintain another pin set, or how are we going to GC the way that we can do GC a little bit better? But in that case, you will have control over at least not GCing things while you are adding and these kind of things, right? So you will get some advantage. But that is one of the things that you could do. There are other things that could be done regarding how things are architected and how data is moved around between peers and components in the peers and so on. That could also be working.
Makes sense. If somebody was to run they needed multiple regional support right now, I think Val, you said that you guys are looking for that as well. Would you recommend running multiple clusters right now? Or I see that on the roadmap. I'm curious kind of like if that's a high priority or if we'd be better off kind of looking at running multiple clusters at this point.
What is the alternative to run multiple clusters? Sorry, I didn't understand.
For companies that are looking to have like regional specific strategies. So this content goes in Europe, this goes in America, this goes in Singapore, right? I saw on your roadmap that you're looking to add more allocation strategies specifically by geographic location. Is that something that's pretty high on your guys' priority list right now? Or for companies that would be in that position, would they be better off just running multiple clusters and then just kind of allocating on a specific cluster basis based on where they need the content to go?
Yes, I think this is a problem that you can solve on top. You can run a single cluster, spawning all your regions, and you can define the allocations for your content manually. So whenever you pin, you could manually say, pin only on those peers, and you have the information that those peers are in certain regions.
Gotcha.
Or you could run separate clusters in each region. But then I would like to hear what is your plan on top to coordinate. So potentially both solutions will be fine, but you will have software on top deciding where to send the pins and so on, and you will have to wait whether it is most useful for you to have separate clusters which are independent, which you can potentially work with completely independent from each other, or whether you'd rather have a single cluster so that nodes in different regions also have the possibility to essentially have the state for the whole world. Yeah, that is something that
it's definitely use case dependent, but it sounds to me like basically there is a way to run one cluster and then essentially you as the user keeping track of the metadata that you have a peer called Singapore and a peer called Stockholm, and that would solve the problem.
Yep, that's kind of what I'm hearing too.
Yeah, a cluster of clusters just sounds like I'm like, and then we need a cluster manager or something on top of it, like.
So that
definitely use case dependent, I would say.
Yeah.
There is the idea of clusters of clusters. It had a name, I forgot about it, but the the cluster peer offers an IPFS API, the IPFS proxy API. So you could potentially have a sidecar to the IPFS proxy API, which is an IPFS peer of an over cluster, of a cluster on top of the cluster. So you could potentially run one cluster in every region, and then have a peer which is part of a global cluster, and then you could do things like that. But I think it's very interesting to think about that. But when actually running things, it just adds a level of complication that you could normally, you wouldn't need otherwise.
Yeah.
But yeah, if we add the pinning services API to the cluster so that they expose that, we could also have a pinning services client which will talk to that, and you could actually build these hierarchies of cluster in ways that maybe make more sense than right now, because the proxy API is limited. So maybe one day that use case has a little bit more sense. Also for things like permission control and things like that, or collaboration between organizations, where every organization runs their own cluster, but then you have a general cluster that sort of orchestrates content between the different organizations, or just make sure that you send a pin to all the organizations. It may be an interesting use case for that thing, but it never materialized because I think it's just too complex.
Super helpful. This is good information.
Awesome. Jeff, anything else for us that we want to cover live?
So I don't have a topic yet. We were talking about doing a monthly call, which the inaugural version would have been last week's IPFS operators call. This is kind of a special event today. So if we did a call on August 3rd would be the next logical date. Please get in touch with me through the Slack if you have suggestions for something you'd like to talk about, or you'd like someone else to talk about. Let's talk about it in that Slack channel. I've asked a couple of people if they would be interested in specific topics, but I haven't heard back yet, so I won't call them out right now. They aren't even in the call anyway. But if you have something you'd like to discuss for next month's August 3rd meeting, please let me know, and I'll get the Luma invite up later today. And Luma will, of course, spam the heck out of you until you actually register, and then it'll keep spamming you until you attend.
Awesome. Hector, thank you again very much for being available before your vacation. Enjoy your time in Spain. I'm now going to hit the stop recording button.
Thank you.